Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. This week I'm going to finish up the table, and I'm going to start by affixing one of my mini clamps to the pallet that I've made. And I'm going to use a 1, 2, 3 block here to set that clamp square. So a little pressure against the 1, 2, 3 block, close the vise, cinch down the clamp. This establishes a vertical surface. This simulates a second vise. If you don't have a second vise, this is a good setup to achieve the exact same result. Put the part in, jam the part to center. The x-axis table is now zeroed out. Clamp the part in securely so it doesn't wiggle back and forth. Pick up the back side edge. As soon as it kicks out, dial into the required dimension and lock everything down. The table is now exactly where it needs to be for the features going in from each end of this part. These holes are called out as concentric, and about the only way to assure that they are concentric, if you don't feel like picking up each end of this part and making the feature, well, this setup will work like a charm. The holes on either end are different sizes, and I drilled and reamed both ends accordingly. Locating the other side is a breeze. Unloosen the clamp, flip the part around, re-register the part. Nothing's changed. The table hasn't changed. Nothing's moved. The clamp hasn't moved. The 1, 2, 3 block, the vise didn't open, and off we go. I love it when I can do a setup like this. It makes the location of the required features a whole lot easier than it would be if you decided to do it any other way. And like I said, if you have a second vise, squeezing a second vise in that primary vise is a good way to achieve this exact same setup. But make sure you take the handle off the primary vise so you don't accidentally release the secondary vise during the procedure. The height of the part has got to be brought down about 1 millimeter, about 35 thousandths of an inch. And I will finish these surfaces with the dovetail cutter that will ultimately create the feature that I am looking to address right now at this moment. There's no dimension on the print for the thickness of each of those elevated bosses. So at your discretion, clean up the casting to suit, like I did just there. The dovetail cutter itself, the height is set by rolling another pin underneath the bottom of it and raising the table the thickness of the pin to the required depth of cut. Never set that height of that cutter with that pin directly under the cutter, or you risk chipping the edge off the cutter. I'm going to get this to a point where I need to check it, and we're going to stop and explain something that's going on. All right, before I finish cutting this particular dovetail, it has presented an unusual circumstance that I figured I would point out to you and maybe help you to avoid a problem, not the problem I'm having, but the problem does exist. I always like to use a pin that is very similar to the depth of the dovetail. It just makes the math easier, in my opinion. Well, in this particular situation, with the dovetail being called out as 500 across the points, and the part itself is only 500 wide. Okay, here comes the hush comes over the crowd, right? I think you can see where I'm going with this. There is no tangent area out here for this pin to sit. So if this pin were to go tangent to this surface and roll into this point, the pins would be closer when you had your, well, let's just say it would be closer than what you're looking for, and it would give you an incorrect reading. If you're going to do something like this, you're going to have a dead sharp corner here and do some fancy math, or you're going to have a smaller pin that fits in here and can still go tangent here and tangent here. And then there's your over the pin measurement right here. I'm using 70 thou diameter pins for this, and calculated it's about a 546 Actually, it's 545 and 8/10 over the 70 thou diameter pins. All right, that's what I'm shooting for in the next frame. You cannot use the 126 pins outside the dovetail being 500, the part being 500. You've got a situation that would give you a false reading, so be very careful about that. Very important. All right, let's get back and finish the dovetail. When I reposition this cutter for the final cut, which is coming up, watch how the cutter goes beyond where it needs to be and comes back. It happens quick, right there. The dial was turning clockwise on the y-axis, so when I shift to the front, I'm still turning clockwise, and backlash is not an issue. I will get a very accurate cut doing it that way. Checking it with the pins right now, we're going to figure out exactly what the over pin dimension currently is versus where I want to be. And we're about 1/1000th of an inch-ish over where I want to be. So I'm going to take one more pass, and that also rules out any flex in the cutter. I'll do the same thing again. Watch me go beyond it and come back. There you go. Small move. Clockwise on the dial, just dust in the coolant. And the finish pass across the front. Before we get on to putting those pieces together and showing you what it looks like, I'm going to make sure that I have all the pieces necessary to do that. And the only way to complete that table assembly is to make the saddle weigh. This is the modular piece that holds the table in place because of those elevations on the ends. Well, it's a relatively straightforward little piece. 1/8 inch, 1/4 inch wide. It's going to be 7/8 of an inch long. That's 7/8 of an inch long. And then we have a 60-degree angle to a 172 theoretical. Now, I suppose you could probably blue this thing up, scribe a line on there, work to a line. But if you wanted to hit that and hit that correctly, well, this is how I'm going to do it. Let me zoom out on that for a second. There we go. The 172 dimension given on the print right there to a 60-degree corner, or right there. I'm going to press it up against the block and put a 100 diameter pin in there. And I'm going to measure the stack height over the 100 diameter pin. That's about 309. And I suppose either way on that, a couple of thousandths is not going to hurt. The slop will most likely be taken up by the screw, the through holes for the little retainer screws. So that'll be done in a second vise, so I can pop it in and out and measure it accordingly. And very straightforward little piece. Let's pop it in some aluminum jaws, mill it off the ends, put the holes in, and then we'll work on this in a second vise. One of the big problems with a part when it starts getting small is access to the part to set the tools for the features that you want to create. Now I'm going to do this entire part without ever touching an edge finder, an indicator, or any type of device, just knowing the size of the cutter. Now I am not a fan of using a 2-flute cutter on steel because I like my 2-flute cutters nice and sharp to do the aluminum work and get a nice finish. But I'm going to be stuck between a rock and a hard place here because the jig is going to be made out of aluminum. Okay, aluminum jaws. Well, you may have seen these in another video I did. These are actually 45-degree jaws for holding round stock, and this side is stepped for holding a variety of flat stock, but this situation, I'm just going to use it a little differently. I have a 1/8 parallel in between these aluminum jaws right now, and I'm going to close the assembly nice and tight. Okay, pressing down on it, closing the vise, all is well. I'm going to bring the cutter down and visually center it on this slot. Now when you do something like this, pay attention to the rotation of your dial if you don't have a digital readout, and maybe even if you do have a digital readout. I'm going to make sure that when I position my table that my dial is turning clockwise. Clockwise pushes the table in away from you. Okay, so let's do that. I'll slip the machine out of gear and rotate that so that the wide part of the cutter will cover the span of the gap. 1/8 inch gap, 1/4 inch cutter. It's going to be a very minimal cut. This is strictly by eye now, so precision at this point doesn't matter at all. come back for it. I like that right there. My table just moved into position with my Y-axis dial turning clockwise. This is where I'm going to set my digital readout, Y-axis to 0. Okay, all goes well. Watch what happens. I'm going to cut a small trough in there that this is going to sit in. All right, here we go. I guess it works better if it's in gear, huh? This particular technique is called ramp cutting. As I'm walking back and forth for the length of the slot, I am raising the table. So each one of those is actually a tapered surface until the very last cut, which is a flat surface. Okay, step one, the trough is cut in the aluminum jaw, longer than the actual part. What do we know about that trough? This is a 249 cutter, so it's about 125 to the center of that existing feature that I just cut. Now when I open the vise, it's still going to be 125 off the back edge. So I'm going to bring the table towards me, 125, and now I have my 0 edge on the back. Okay, no edge finders, no indicators, no nothing. Open the vise. Clear the debris. Remove the shim in the middle, parallels coming out. I'll put the part in. And just because I like the jaws moving with the vise, I'm going to put a spring in there. A piece of spring steel down in between them. Away we go. Okay, let's reset the table. The only reason I moved the cutter down is so that you could see the table move. I'm going to go back to 124.5. And I'm going to zero the digital readout. That now gives me the distance from the back contact surface to whatever center line I want to put in there, which is good for when I have to drill the holes. I don't need to do anything special in order to drill those holes. I'm going to establish the center of the part and work all the dimensions equidistant from the center line of the part. And I'm going to do that by milling one end, zero my digital, mill the other end, go to the center line feature, and back to the center line. So now I have two axes. Everything's lining up. Let's do it. With one end of the part successfully cleaned up, like I said, zero out the digital right now. X-axis. Make your shift. Be very careful that you don't overstroke the Y-axis cut and run your cutter into the jaws. Stay within the confines of the aluminum shim. The thicker the shim, probably the better. Excuse me, the wider the shim, the thicker the better. Now this end, all I want to do is get to a point where I can clean it up and have an even number on the digital. So when I raise the Z-axis, when I raise the cutter up off the part and hit the center line button, I'll come back to the center, and then I know I'm right in the middle where I want to be. Access to the overall length of the part is very readily available. A pair of calipers on there and you got it going on. Nice trough. Let's zero out the center line feature, get on the middle of this part. There you go, with the center line feature established on the digital readout, and I'll show you how to do that after the fact. But with the center line feature now, everything that I need to do to establish the width of this part will be an equal move left, equal move right. Knowing the diameter of the cutter, knowing the overall length required, you don't even need to do anything fancy to figure out the overall length of the part. Split the overall length of the part in half, split the cutter in half. That's your digital move in both directions. Overall length of the part established. I'm going to return to the center line 0 and the XY 0, dead center in the back of the part. Drill chuck, we'll pop the holes in. Up to this point, I have not touched an edge finder. I am trusting the diameter of the cutter and the digital readout to give me everything I need. I'm going to pop the 2 holes in, the counter bores, and we'll take it out, put the angle in. I'm going to start these 3 holes with a center drill. And I'm going to go nice and deep. I'm going to go much deeper than the diameter of the drill because I know these end holes are going to be counterbored. And we're just going to drill it through for the screw. This is going to be an 0.62 millimeter and a half drilled and reamed for the final operation. The setup for the 60-degree angle on the end is pretty straightforward if you have 2 vices. The part is nested in between some aluminum sandwich blocks so that I can overcut the part, not hit the hard jaws, which never ends well. The vise is simply tipped up at a 30-degree angle, so the resulting cut will be 60 degrees. I'll take a dust cut until it cleans up to a sharp point. I'll take it into inspection, put a pin in there, measure the height, adjust accordingly, and finish. Let's cut it. Guys, it is very important before this part goes into inspection to check that angle, that you take any burrs that are present off of this part. Very important. My target height to check this little chamfer is 309 over a 100 diameter pin. So the first thing I'm going to do is set my drop indicator to 309. Actually, I'm going to 0 it at 309 so I know when my digital, or my dial, let's change the camera angle here for a second. So with the gauge block stack set at 309, the dial is set at 0. That just gives me a very easy reference as to how much to take off. The part setup itself is pretty straightforward as well. I am using 2 blocks like a little mini vise. I'm going to squeeze them together like that, drop the pin right in there. The slope on the part will allow the pin to go against the back side of the back jaw. Holding these tightly, just bring it down on top of the pin. Tells me I got about 23 to take off of that surface. This pin needs to migrate vertically 23 thousandths. All right, does that mean I'm going to go raise the knee on that machine 23 and get a good cut? Nope, it's not. Show you what's going on with that. All right, this is the 100 diameter pin that I just checked the top of. It has to come down 23 thousandths, which means the surface has to come down 23 thousandths. That's the only way this pin is going to move. But if I was using a form cutter, if I was using a form tool of any sort to cut that angle and this part was sitting on the machine vertically, 23 would be a correct move. But the part is sitting in here at an angle because of the 2 vise setup. So it's not the 23 that I want to move. It is the base leg of the triangle right there. And by higher math, 23, which is the hypotenuse, 30, which is the nose angle, 19.9, just about 20 thousandths of an inch elevation on the table. Should put that pin on the 23 that I'm looking for and give me the 309 stack height for the 172, and the knee bone is connected to the hip bone. Off we go, back to the machine. 20 thou more coming off, part should be gold. All right, guys, well, I say that's probably good enough. Let's go out to the bench and put the stack together. And just like the other component or components in this stack, I did radius the nose of this so that it would fit inside the dovetail, yet to be tested. Let's go put it together, take a look. Dovetail worked out well. When you do this, make sure that you round off the corners of the dovetail to accommodate the radius on the inside as well, because here's the mating part. When they go together, see the opposing, see the Z right here? Look at the tip here and the tip down here, and you're going to want to see light right there. And you do. That way you know it's mating on the surfaces that it's intended to mate on, and those corners are not doing the interfering. Because over time, if it was just the corner hitting, the corner is going to wear down quickly, produce debris, and mess up your day. So make sure you round those corners off real good. That is a really nice fit on there. Of course, because it's a one-sided dovetail, it doesn't get any easier than that, boys and girls. A little plate goes on here to make up the other side of the dovetail, and I would have to think that they did that because, well, that boss hangs down further than the dovetail, and you wouldn't be able to install this thing if it was just cut right directly into the block. And this is what I'm talking about right there. Okay, after a little fussing around with the Allen key to get this thing to seat properly, it's very easy to cause a pinch right there, and that is something you don't want to do. Make sure you radius the tip of that before you put that on, or it'll register down in the corner. But for now, I think I like what I see. That was time well spent. Thank you very much for tuning in, guys, wherever you are in the world. I hope you're well, happy, and safe. All of the above. I'm Joel Pye at Advanced Innovations in Austin, Texas. I'm out. Okay, for all of you guys that stuck around wondering where does he get his pin dimensions from, let's see if I can knock some of that stuff out real quick. Show you exactly where they come from. It's not as hard as you would think. You're going to get something on the dovetail, and I'm going to really make this ugly so that you can figure out what's going on here. I mean, like, seriously ugly. You're going to get an angle of the dovetail, and you're going to get a dimension somewhere. Top, bottom, something somewhere. Let's say this is a positive feature here, okay? So this is something that you can hook your fingernails onto. This is not a negative female dovetail. This is a positive. The dovetail that I just did was dimensioned here. It was called out as a 500 theoretical, because very rarely are you going to cut a dovetail to a dead sharp corner. On mine, the model I just did, I had to remove those corners. So in reality, the only way you could check that is with pins or a comparator. So there's dimension number one. That's incredibly valuable right there. Only 500. Now I'm just going to give you the mechanics here. There's several different ways to do this, but this is probably the easiest one to look at. The height was also given. I used 126 for mine, so that the casting would clear this back surface and doesn't have to be shaved down. All right, let's just pick a pin, a random pin. Let's say 80 thousandths in diameter, about 2 millimeters. Okay, if you happen to have a piece of 080 stock laying around. Maybe even a piece of welding rod, like 3/32 welding rod, coat hanger, whatever, you know, something that's straight and reliable. Let's put that right in here. Like, okay, Joby Wan, work your magic. Show me how to figure out what it is over the pins, right? It's like, big deal, I have a pin laying in there. So what? Well, here we go. Boys and girls, hold on to your socks. First thing I do is right here. There's your triangle. Figure this triangle out right there. You know what this base leg is, and you know what that angle is, because you know what this angle is. It's a 60-degree dovetail. So pick it. 30, 60, 90, 126. There's your mechanics. Once you have figured this out, you can back it out of here. And you know what this is right here. You will know what that gap is. Is that important? Who knows? Let's find out. Where do we go from here? Well, you know the radius or the diameter of the pin is 080, so you know the distance from here to here, in a straight line, is 040. Right? That's handy. Now make sure you do everything in doubles. What else? How do we find out where the center of that pin is, or where that pin is located? Well, it's also pretty easy to do. If you know that this is a 60-degree dovetail, this distance from here to here is the radius of the pin. This distance from here to here is the radius of the pin. And as that pin sits in this dovetail feature, it bisects that angle. Right there. Two identical triangles are now formed because you stuck that pin in that dovetail. This is the working triangle right here. That one. I'm even going to color it in black so you can see it. Once you know what this distance is from here to here by solving triangle number 1, you can now work from this point here over to the center of that pin by solving triangle number 2. And once you've done that, you know what the distance is to the center of that pin. Add the radius. Ta-da! Like magic, boys and girls, like magic. And then you have your dimension over the pins. Okay? Not hard at all. The dimensions are there for the asking. Just take a second, write it down, look it over. Triangle number 1, triangle number 2, plus the radius, times both sides. There you go. Bada bing, boys and girls. There will be a quiz. Hope you enjoyed that. Hope it helps. Now, there are other ways to do this. I'm sure there's formulas out there, but if you want the nuts and bolts of it, that's the easiest way to do it. Thanks for sticking around. See you guys.